Okay, so now let's talk about the network security, DDoS, and web firewalls, and so on. So first, network security at its lowest level, we have a VPC, a public subnet, and an EC2 instance. Uh, the first thing to protect our EC2 instance could be a security group right around it, and it would be attached to an ENI, Elastic Network Interface. So your Elastic Network Interfaces, which is how your EC2 instances accesses other networks, for example, your private subnet or your internet stuff like this. And so it's for the EC2, RDS, Lambda. In VPC, security groups can be attached to anything that is going to be in your VPC. So the security groups are stateful. Okay, security groups are the stateful, that is the traffic is in and the out also. That means that any traffic that is going in is allowed and go back, and vice versa. Any traffic that goes out is allowed to go back in. So this is quite helpful because you don't need to worry about a request coming back if you are doing a request outside. And you can reference other security groups by group ID, or you can reference have rules by CIDR. So CIDR block IPv4 or IPv6, and it supports security group references using VPC peering. So it's possible to reference a security group that exists in another VPC that has a VPC peering on even in another accounts, but default it's inbound denied and outbound all allowed. Okay, so if you want to allow a stuff inbound, you need to add rules, and if you want to restrict outbound, you need to remove rules. So there is no deny rules in a security group. A security group is just allowed. Okay, just allow rules are available in the security group. Now next we have the network ACL, that is for short called the NACL, NACL in ACL, and that sits at the subnet level. So the network ACLs are going to be helpful for a line of defense before the network reaches your instance and your security group, and so it's attached at the subnet level, and it's going to be stateless. That means that you need to define both inbound and outbound rules, and that will apply for all the traffics. So it's not necessary that one goes in can go back out. So you need to be very careful about how you set up your network ACLs. From network ACL, you can only reference a CIDR range, not a subnet, not a group, no host name. So you can only define a CIDR range, and that range can be whatever you want. Like it can be IPv4 or it can be IPv6. The default network ACL allows all inbound traffic and allows all outbound traffic. Well, when you create a new NACL, you will be denying all inbound traffic and denying all outbound traffic. Network ACL can have deny rules, so it's very handy to have a line of defense against the specific IP. Maybe you are having some of the attacks from the specific IP. So it's very big difference between security groups and the network ACLs. You can deny traffic in network ACLs, but you cannot deny traffic in security groups. Okay, and then finally, if your traffic goes all the way to your EC2 instance through your network ACLs and through your security group, you are more than welcome to set up a host firewall on the EC2 instances. So it's software based, it's highly customizable. There's no AWS specific software for doing host firewall, but it's up to you to find something that you like and have this extra level of protection on your EC2 instances. So next we will be talking about the DDoS attacks. So what is a DDoS attack? So DDoS stands for distributed denial of service. So it's a way to basically shut down an instance by making it sure it cannot accept any new traffic. Effectively, we are making it useless. So your users cannot access your application anymore. So the way it works that you have an attacker and you have application server, and the attacker through some various techniques, I will not get into the detail, So we'll be able to have a bunch of computers that are going to be going to be masters, and they are going to be creating bots, and the bots will be a lots of them, and all the bots are going to get into the requesting stuff from our application server in very bad ways, non-conventional ways. And so the application server is overwhelmed. It doesn't know how to respond to these requests. It's going to try as best as it can, but it's gonna be very soon overwhelmed, and then it will just done. So there will be a denial of service in such case, and so your normal users cannot access your application server because it does not respond anymore to normal requests. It's very dangerous, but it's very common on the internet. And so there are different types of attack on your infrastructure. So there is DDoS, and so it's when your service is unavailable because it's receiving too many requests at a high level. So there's different ones. There is SYN flood, which is a layer 4 type of attack. When there's too many TCP connection requests happening, there's a UDP reflection, where the other servers can send a big UDP request to our server. DNS flood attacks, where we overwhelm our DNS so that the users cannot query our DNS service, and they then can't our website also, which is bad situation. Then the slow loris attack, where a lot of HTTP connections, where a lot of HTTP, so it's a layer 7 or so it's a layer 7 are open and maintained, and our server is trying to maintain all of them, and the threads are being overwhelmed and the server is useless. So then there's a application level attacks, which is more complex, and you need to understand how the target application works to make it an application level attack. So before it was network based attack, that's application level, and so you have some things such as cache bursting strategy to overload the backend database with a request to invalidate the cache, or you request too many things, or you send too many big packets. It just depends on your application. And the kind of the security holes your developers may have introduced while programming your application. So okay, so now how do we get protected from DDoS and these application level attacks on AWS? So well, first for DDoS there is AWS Shield standard, and it's to protect against DDoS attacks for your website application for customer at no additional cost. So by using AWS, you are somewhat protected against to Shield standard enabled by default for against some DDoS attacks. Then you have Shield Advanced, which gives you 24/7 premium DDoS protections, and we'll see in the detail what that means in the next slide. You have WAF, AWS WAF, or Web Application Firewall. And this is not specifically for DDoS, but it can help you filter a specific request based on rules. So for example, you can say if the request is more than 5 megabytes, then drop it right away because this looks a bad request. So Web Application Firewall WAF is more against application level protections, but it can still help you filter some specific request based on rules and help you survive a DDoS attack event. So we have CloudFront and Route 53, which is by default have the Shield enabled, and they will give you availability protection by using your global edge network. So attacking CloudFront and Route 53 is a lot of work, and combined with Shield, it provides DDoS attack mitigation directly at the edge of your network. So the traffic never really makes it through your core application in any region or in one region. And finally, in case the traffic does reach your application, then a very good way to protect yourself is to be ready to scale. So you need to leverage AWS auto scaling, such as if some of your servers are overwhelmed, that means your CPU is skyrocketing close to 100%, then auto scaling will kick in and like create more instances, and so it's going to become more expensive for your attacker to attack these new instances. Obviously it's gonna be more expensive for you, but you are having some kind of protection against these attacks. And then finally, it's a very good idea to separate static resources and distribute them through S3 in CloudFront, which is visually very safe and keeps stable from a DDoS, from dynamic request, which are going to be usually a smaller request, and that you can handle for the REST API on EC2 and ALB. So if you are more interested into DDoS protection as whole, I recommend you read this white paper available on the AWS DDoS white paper. Go through this link. Okay, so as a sample architecture to protect yourself against DDoS, you have the DNS service route 53 that is protected by Shield by default. Then you have your application distributed by CloudFront, where Shield is again enabled by default, and you can set up a web application firewall on your CloudFront distribution to protect yourself. Finally, if the traffic does make you through, then your load balancer you also have Shield, and then if your application makes you through to your auto scaling group, then it's able to scale over there and make sure you can handle the extra bits of the traffic from the DDoS attack. Now let's get into the AWS Shield. So Shield has two levels of services. Shield standard is free and it's activated for every customer on by default, and it will provide you protection from SYN attacks, SYN attacks, UDP floods, reflection attacks, and other layer 3 or layer 4 attacks. Very good. Very good. Shield Advanced is more enterprise customers. For a more enterprise customer, it's an optional DDoS mitigation service. Is going to cost you around $3,000 per month. So it's very costly, and it's mostly will be suitable for the enterprise organizations. And you are going to be protected against more sophisticated attacks on your EC2 instance, Elastic Load Balancer ELB, CloudFront, and AWS Global Accelerator, and even the Route 53. On top of it, if you do experience the DDoS, then you have 24/7 access to the AWS DDoS response team and the DRP, DDoS response team, DRP for short. And on top of it, if you incur higher fees because you are scaled up with auto scaling, because you have more requests going into your network, more bandwidth, then you are protected against these higher fees thanks to the Shield Advanced sort of insurance that you took with the $3,000 per month fees. So it's very important for you to understand the difference between these two and understand which one is to use in the exam based on the enterprise and somewhat a smaller company. Next we have WAF, Web Application Firewall. Web Application Firewall allow you to protect your web application from common web exploits at the layer 7. So this is the HTTP layer. You can deploy it on the application load balancer to get localized rules. You can deploy it on the API gateway to get the rules running on the regional or edge level. You can deploy it on the CloudFront, and these rules are going to be rarely running globally on all edge locations where CloudFront is. And this could be used, for example, if you wanted to have a web application firewall for your cloud load balancer, classic load balancer, your EC2 instances, custom origins or S3 website, you would have CloudFront and then deploy web application firewall WAF on the CloudFronts. You can also deploy it on AppSync. And this is going to allow you to protect your GraphQL APIs directly. So remember that WAF is not used for DDoS protection. So this we have Shield. WAF is used for layer 7 type of exploits. So for this you are going to define web SEL So the web access control list, web ACL, web access control list, and the rules can include IP address filtering, HTTP headers, HTTP body, URI strings. Uh, you can have common attacks protection such as SQL injection or cross-site scripting, XSS. You can have size constants to say, hey, any request bigger than 20 megabytes, uh, 20 megabytes once. You can have a geo match to block or allow a specific country based on the IP addresses with the geo match, and you can have rate based rules, so to count occurrences of events and say, hey, if this happened more than 5 times per second, this looks fishy, block it. So something super important for you to know is that the WAF has managed rules. Web Application Firewall has managed rules, and you need to know it for the exam. So there are over 190 managed rules, and I'll give you some of the most important example. As an example, they are ready to use managed rules and will be from the AWS or the marketplace sellers, and they'll allow you to just power up Web Application Firewall very quickly, very quickly. So you get baseline rule groups, which is general protection from common threats, and this include the managed rule, uh, common rule sets, the managed rules, admin protection rule sets, and so on. So they are just baseline for common protection. Then you have use case specific rule groups, and they give you protection from many use cases such as the SQLI SQLI rule set. Then we have Windows rule sets. Then we have PHP rule set. Then we have managed AWS managed rules, WordPress rule set. So to protect these kind of application, PHP application, WordPress application. Then you get the IP reputation rule group. So, and this is to block. So IP reputation this is to block request based on the source IP. So for the example, you have a malicious IP, and there is this very important rule called the managed rules Amazon IP reputation list, which is list of all IPs that are trusted by AWS and those that are not trusted by AWS, and this can help you block spammers very quickly. You can also get anonymous IP list as a rule, and so on. And finally, there's a bot control managed rule group to control the managed request from the bots. So this includes, for example, the AWS managed rule bots control rule sets. So as you can see, we have 4 kind of managed rule buckets: baseline, use case specific, IP reputation, and bot control. Anything that can come up in exam is one of these, including the Amazon IP reputation list. Okay, so what about logging for Web Application Firewall, WAF? So this is also something that can come up in the exam. So while Web Application Firewall can send logs to Amazon CloudWatch log groups, and you can get a debit of 5 megabytes per second maximum. Per second maximum. So you can also send it to Amazon as free bucket, and the logs will be sent to every 5 minutes. Or if you want to have more control, well, you can send it directly from Web Application Firewall to Kinesis Data Firehose, in which case you are only limited by the Firehose quotas. Well, why would you do this? Why would you consider the Kinesis Data Firehose? Well, for example, if you have very high traffic, very high logging capacity requirements, then using Kinesis Data Firehose, KDF, could be a very good thing. And then for the Kinesis Data Firehose, you can send it to any destination supported by Kinesis, such as Amazon S3, Redshift, OpenSearch, and so on. So finally, to manage all your firewall rules of Web Application Firewall, you have firewall you have firewall, you have Firewall Manager, and that helps you manage all the rules in all the accounts for AWS organization, for an AWS organization. And so you can define a common set of security rules. So this applies to web application firewalls, which again can be applied on your application load balancer, API gateways, and CloudFront. You have to remember this, that it can be again applied to the API gateways and the CloudFront. We can define the rules as well for the Shield Advanced, and the Shield applies to application load balancer, classic load balancer, Elastic IP, and the CloudFront. Your security groups for EC2 and Elastic Network Interfaces, resources in your VPC. So you can manage them centrally from the Firewall Manager, and that's it. So that's it for like all this lecture on network security. It's a lot of new content, I know, but what you really need to remember is the difference between the Shield and the web application firewall. The fact that the web application firewall can only apply to application load balancer, API gateways, and cloud fronts. All the rules that can be applied in web application firewalls, the level of Shield, standard, Shield, advanced, and the understanding how network security overall works in AWS. In some of the next lecture, I'm going to show you some more diagrams to you for you to clearly understand how all these things fit together. So we'll see you in the next lecture.